Day 486 of doing a LeetCode problem every day until I get a job. All right, y'all, we're back again. Another day, another LeetCode problem where we're doing daily LeetCode problems. And today we have question number 1792, maximum average pass ratio. The difficulty level is medium, but don't worry because you already know we're going to keep the solution as simple and easy to understand as possible. But before we get started, y'all, don't forget to like, hype, comment, subscribe, and share. And if you need any new Apple AirPods, go ahead and check out that link in the description so you can get you some. Now let's see what the question says. There's a school that has classes of students, and each class will be having a final exam. You are given a 2D integer array classes where classes of i's equal to passes I and total I. You know beforehand that in the ith class there are total I students or total students, but only pass I number of students will pass the exam. You are also given an integer extra students. There are another extra students, brilliant students that are guaranteed to pass the exam of any class they are assigned to. You want to assign each of the extra students to a class in a way that maximizes the average pass ratio across all of the classes. The pass ratio of a class is equal to the number of students that the class will pass the exam divided by the number of divided by the total number of students of the class. The average pass ratio is the sum of pass ratios of all of the classes divided by the number of the classes. Return the maximum possible average pass ratio after assigning the extra students. Answer within the tenth to the negative fifth of the actual answer will be accepted. So first, let's just say go over this. This means that we can return answers up to the fifth decimal place. Before we get into the solution, let's go ahead and take a look at these examples just to make sure that we are doing this question correctly. So in example 1, we have our input classes equals an array of integers 1, 2, 3, 5, and 2, 2. Now, let's pause right here. I'm going to copy and paste this over here because I feel like this example is a little tricky just because it gives you 2 students. Well, it's not tricky, but I want you to fully understand what's going on. And once again, as y'all know, I want this to be easy to understand. And the 2 students are just making it harder to understand. But all we really want to do, so we're going to take the same example, but we're just going to have 1 extra student just so I can explain it better and make it make sense a little more. So this is the same example, but what we want to do is we want to place the extra students in class where adding 1 passing student and 1 total student gives the biggest increase to the pass ratio. So what does that mean? Let's go through it. So and we have our classes, a 2D array of integers, right? We have first class has 1 and 2, or the first array is 1 and 2, second array is 3, 5, third array is 2, 2. So first let's go over what these arrays actually mean. So this element right here, index 0 in the array, is the number of students that will pass the class, and this is the number of students, the total number of students in the class, right? It says right here, passive I, total I. Boom. So this is the number of students that will pass. This is the number of students in the class, right? And that's is for each array. So once again, this same thing. This is the number of students that will pass. This is the number of students that are in the class. Same thing here. This is the number of students that will pass. This is the number of students that are in the class total. Boom. So, and just for the sake of this example, we're only going to have 1 extra student so I can break it down to y'all more. I know in example 1, we're going to go through example 1 too, but I know in example 1 is 2 students, but I feel like 1 student will just so you could get a better gist of what's going on. So once again, we want to place this 1 student in a class where adding the 1 student and 1 total student is going to give the biggest increase to the pass ratio. So let's go through it. So if we add this 1 student to class 1, right, now class 1 has 2 students that'll pass and 3 students that are total, right? And so it says the pass ratio of a class is equal to the number of students of the class that will pass the exam divided by the number of students in the class. So we're taking the number of students that will pass and we're dividing it by the total number of students, right? So in this case, we're going to do 2 divided by 3. That'll give us the pass ratio. Now we want to once again add this student to the class that will give us the biggest increase in our pass ratio. So if we add the student to this class, right, then we're going to have, now we have 2 students that'll pass, 3 students total. When we started with 1 student that'll pass and 2 students total. So that gives us an increase of 0.167. Boom. If we add the student to this class starts at 3 students that'll pass and 5 students total. So now we'll have 4 students that'll pass and 6 students total, right? That has then when we do 4 divided by 6 minus 3 divided by 5, our increase will be 0.067. That's the increase of the pass ratio, right? That's how much the pass ratio will increase. Then see, this is 2 and 2, so this has 2 students that'll pass and it's 2 students that'll total. So the pass ratio is 1. So we go from 2 students that'll pass to 2 students that'll in the class total. If we add the student to class 3, we'll go to 3 students that'll pass and 3 students that'll in the class total. But that isn't really an increase because 3 divided by 3 is 1. 2 divided by 2 is still 1. So 1 minus 1 is 0. So there's no increase because it's already 100% of students that are passing, right? So if it's already at 100% of students that are going to pass, we can't really increase that. So this increasing, this will stay 0. Now we see that class 1 is going to give us our biggest increase. So that's why we're going to add the student to class 1. So that's just a better visual example of why we choose which class, or how we choose which class to assign the extra student to. So now that we understand the inner workings of what we're trying to do, let's go through these examples. So in example 1, we have an input classes equals to 2D array of integers. First array 1, 2, second array 3, 5, third array 2, 2, extra students equals 2. The output is 0.78333. Explanation says you can assign the 2 extra students to the first class. The average pass ratio will be equal to 3 divided by 4 plus 3 divided by 5 plus 2 divided by 2 divided by 3, because there are 3 classes. So we want the average pass ratio is the sum of pass ratios of all the classes divided by the number of classes. So this is the pass ratio for this class, pass ratio for this class, pass ratio for this class, all of these classes. This class got the extra 2 students. So once we did that, we need to divide all of these classes by 3 because there are 3 classes to get the average pass ratio, and that ends up being 0.78333. Now, that's why I wanted to give y'all this example so you can see why they decided to put these 2 students in this class. So let's take a look at example 2. Example 2 is the same principles. It's just a little bit larger numbers. In example 2, we have our input classes equals a 2D array of integers 2 and 4, 3 and 9, 4, 5, 2 and 10. Extra students equals 4, and this time the output ends up being 0.53485. So now that we understand the question, y'all, let's get into the fun part, the actual solution. Solution is not that difficult at all, so let's get into it. Now, the first thing we're going to want to do is we want to import collections, because we will be working with heaps. Let me get rid of this. Come right here. Sorry, y'all, I keep clicking that. Right here. So first thing we're going to do is we're going to import collections. Boom. Then we're going to come inside of this class, but outside of the function, because we're going to define a helper struct that is going to represent a class, or which is the students passing divided by the total number of students. So we're going to create a helper struct to represent a class. So we could just call this struct say struct, we can call it class. This class should not be confused with this class. This class represents these classes. So we'll just call it a struct class. Then we will say colon, say comparable, open up the brackets. First thing we're going to do, we're going to get the number of students passing. So we're going to say let pass, colon, that's going to be an integer. Then we're going to get the total number of students by saying let total, colon, that's going to be an integer as well. Now we're going to calculate the gain and the pass ratio if we add one extra passing student to this class. So come underneath this, declare a variable called gain, colon, it's going to be a double, open up the brackets. We're going to say let, open up the parentheses, pass, comma, total. We're going to set that equal to, open up the parentheses, double, open up the parentheses, pass. Then we're going to come outside of those parentheses, still inside the other parentheses, we're going to say double, open up the parentheses, and pass in total. Boom. Then our new ratio, after adding one passing student to the current ratio, we're going to define that by saying return, return, open up the parentheses, pass plus 1. Then we're going to divide that by opening up the parentheses, total plus 1. Then we're going to come outside those parentheses and say minus pass divided by total. Boom. Now we're going to use a comparable conformance, which allows comparison between two classes based on their potential gain from adding a student. So come under this variable, we're going to say static func is less than sign, open up the parentheses, we're going to say LHS colon class, comma RHS colon class. Come outside of that, it's going to return a boolean. We're going to open up the brackets and we're going to say LHS dot gain less than RHS dot gain. Boom. Now that's it for our helper struct. Now we need to get into our function, our main function. So first thing we're going to do is we're going to initialize the max heap with all of the classes. Each element is a class struct sorting pass and total counts. So we're going to declare a variable called classes, set that equal to a heap, open up the parentheses, we're going to say classes dot map, open up the brackets, we're going to say class, open up the parentheses, we're going to say pass, colon, $0, square bracket 0. Then we're going to say comma outside of those square brackets. Then we're going to say total, colon, $0, square bracket 1. Boom. Now we need to distribute the extra students one by one. So we're going to come underneath this. We're going to say for underscore n 0 dot less than sign extra students. Students. We're going to open up the brackets and we're going to take out the class with the maximum potential gain. So we're going to say if let max gain class equals classes dot pop max, put the parentheses, then we're going to open up the brackets and we're going to add the extra student by saying let updated class equal class class open up the parentheses pass colon max gain class dot pass plus 1 comma total colon max gain class dot total plus 1, and then we're going to insert it back into the heap with the updated values by coming underneath this, And we're going to say classes dot insert, open up the parentheses, updated class. Then we're not done yet, but we are getting there. We still need to compute the average of the pass ratio after distribution. So for that, we can just come down here and we are going to say return classes dot unordered dot reduce, open up the parentheses 0, come outside of that, we're going to open up the brackets, we're going to say $0 plus double, open up the parentheses, $1 dot pass, come outside of that, we're going to divide that by double, open up the parentheses, $1 dot total, then we're going to come right here outside of the brackets, and we are going to divide that by a double, open up the parentheses, classes dot count. Now that should be all she wrote, y'all. So let's give it a run before we submit it. Make sure it works how it's supposed to. It's accepted, y'all. That's what I'm talking about. First try. So let's see if it's still accepted after we submit it, though, because we all know how LeetCode can be. And look at that, y'all. 332 milliseconds beats 50% of users. We could get that up, but right now we just want to have the ability to solve the solution, or solve the problem that is presented to us. And I feel like this is a good solution for that because it's easy to understand. And if you don't understand the solution, then you probably didn't learn anything. That's why it's important to understand what the solution is doing. So with that being said, y'all, make sure you get one more look at the code. This is the top part with the helper struct. Boom. Then this right here is the bottom part, the main function. And yeah, y'all, with that being said, I hope y'all learned something today, and I hope to see y'all here tomorrow for another day, another LeetCode problem. See y'all then.